Welcome to myprojectbazaar.com. Now we can going to discuss about the product bidirectional grid connected single power conversion converter with low input battery voltage. In the conversion of two-stage bidirectional converter, it consists of bidirectional converter, DC to DC converter, bidirectional DC to AC converter. In this case, both stages corresponds to power conversion stage becomes each stage is operated by high frequency switching. The bidirectional DC to DC converter performs power conversion between a low power voltage and a high DC link voltage. The bidirectional DC to AC converter is required to interface the high DC link voltage with grid voltage. However, two-stage converter involve bulky DC link capacitor and high switching losses and several semiconductor devices and the gate drive circuits. Additionally, the efficiency of two-stage converter corresponds to multiplication of efficiency at each stages. Thus, it harder to achieve high overall frequency. Furthermore, two separate controllers are required for each stage. Thus, conventional two-stage bidirectional converter involve the circuit complexity and high cost and high power conversion efficiency. Now we can going to discuss about the abstract of our project. Study purpose of bidirectional grid connected single power conversion converter with a low input battery voltage. The proposed bidirectional converter consists of bidirectional DC to DC converter and unfold the bridge and the power conversion stage only correspond the bidirectional DC to DC converter. The bidirectional DC to DC converter can perform the bidirectional power conversion between input battery voltage and rectify the sine wave due to step up and step down voltage regulation functions. Unfolding bridge unfolds the sine wave into grid voltage and provides a current path to the grid. The study also proposed the control algorithm to regulate the grid current through the single power processing stage. The control algorithm is comprised to feed forward nominal voltage compensator and a repetitive control scheme. The feed forward nominal voltage compensators presents a operating point to lighten burn to grid connected control and repetitive control provides a precise control to grid current. Thus, proposed bidirectional grid connected single power conversion converter results a high power quantity and high efficiency. The experimental research is based on 250-volt prototype module can conduct the evaluate the performance of converter and verify the analysis. Now flow diagram of our project. Battery is the one of the charge storage device and it charges the energy. The battery output is fully DC. Next you can see the bidirectional DC to AC converter. The bidirectional DC to AC converter is a grid interface connected between applied in energy control center in order to interface the DC variables such as battery, energy storage system and the conventional utility grid. Such power electronics solutions are guarantees bidirectional flow between DC and AC converter and independent control in both sides. High level of integrations, implementation of two functions using unique power conversion stage. Next we can see about the transformer. Transformer is an step up and step down functions of our even input and output waveforms. Next we can see of the unfolding bridge. Unfolding bridge converter with approximately sinusoidal input currents and bidirectional power flow can realized by coupling a pulse width modulations and rectify the PWM inverter to DC link. The subcategory of power electronics in AC to AC conversions, converting the AC waveform with another AC waveform, it allows the control voltage and frequency and also phase of waveform that are applied to the load of supply waveform. There is number of power electronic switches such as SCR, BJT, MOSFET and IGBT. But reason of using MOSFET in our circuit, most significant advantage of MOSFET does not need current on the control pin but require more voltage. Next we can see about the AC grid. The electrical grid in an interconnected network with deliver the electricity from generation to consumers. It consists of generating stations that produce electrical power, high voltage transmission lines that carries the power of destination source to demand center, and distribution lines to connect the individual consumers. Next we can see about the single power conversion control. It is necessary for proposed converter to perform the bidirectional power flow control and satisfy the utility interface standard. It will only single power processing stage, and the unfold grid current and the input output represent the power flow of directions, and transfers the power line, and it also includes power quality on the grid side. Next we see about the running procedure of our product. The proposed system implementation done in MATLAB version 2013A. First open the MATLAB file window and create a new model file. After creating the arrangement elements as per the circuit diagram, after arranging the elements, the output waveform will be corresponding to the scopes is connected from the circuit diagram. This is a battery output. This is a state of charge. This is charge is decreasing in mode. Next is an voltage. Battery output, it will too low, it will goes to 0, and also its current also and voltage also. Next we see about the grid voltage and grid current. It is a pure sinusoidal wave. Next see about the battery charge. The battery output is fully controls to 0, and it is automatically grid is open. The battery charges. Next you see about the transformer primary and the secondary side of the windings. It's an transformer output.